Hello everybody and welcome to today's session. We'll be talking about Kubernetes for the VIAdmin and what's new for 2021. My name is Kenny Coleman. I am a Senior Technical Marketing Manager at VMware in the Modern Applications Business Unit. Now, with this new format, we have a condensed 25 minutes to get through a lot of stuff. So I'm not going to give you a lot of introductions about who I am or where I came from, but if you want to know more, you can find me online at Twitter as well as GitHub. So what do we know about Kubernetes today? Well, this is where we're going to be a little bit different. Last year and the year before then, we kind of gave an overview of architecture and container basics and kind of what is the overall general knowledge of Kubernetes. But we've now moved across in this adoption lifecycle. We're now into the early adopter and moving into the early majority stage as we now have hundreds of customers that are utilizing vSphere with Tanzu in their own data centers. So if you want to learn more about what we had talked about previously and you want to know more about Kubernetes architecture, or really why do we need containers and where do you fit along in that journey, please go and check out this other video that I had done last year for Kubernetes for the VIAdmin about what we were doing back in 2020. So there's the link right there on the screen. Please make sure you go and check that out. So if you need a primer about this technology and really how it's working and what containers really do and why do you need containers, please go and check that out. Now, just a high-level overview of just really why people love Kubernetes. Of course, we all know that it was a technology that originally originated from Google, but there's a lot more things to it. It takes a lot of cues, I guess you could say, about what we see with inside of the vSphere realm. It is essentially an orchestrator for containers, whereas you see is vCenter is an orchestrator for virtual machines. So you have things like scheduling, but there also are other components into it. You think like in vCenter, we have HA and DRS, which take care of healing and migration, which you see that in Kubernetes as well. So there's a lot of different things that we can see there are commonalities between about what we see inside of vSphere and what we get inside of Kubernetes. But what we're doing is now making vSphere the premier platform to be able to run containerized workloads and making sure that Kubernetes is best ran on vSphere in itself. And coming from my background as well, knowing about how easy it is to take software and make it malleable to the point where you can provision and deprovision software relatively quickly through virtual machines and build clusters, vSphere is by far the best home to do it. And we get a lot of these components that are all built in from every aspect, from networking and storage, load balancing, and we're going to cover all that today. So let's go a little bit into Tanzu additions and why does this matter? So we talked about vSphere with Tanzu a little bit, and that is the core capability of what we need to be able to provision conformant Kubernetes clusters with inside of vSphere. Now, that is just one small piece of the puzzle. Sure, you can go ahead and you can turn on workload management and get going, but there's other components that are needed. How do you get your images from either whatever registry you're pulling from into Kubernetes? Do you need to have that registry live on site as well? Do you want to manage it on your own? You want some sort of registry to be able to make sure you can do that. And Harbor is one of those container registries that is very feature rich and a lot of enterprise features that are built into it as well. There's also other things that are kind of ancillary and outside of it that you would need to think about. So everything that you would like to have for logging and monitoring. So we have ideas, or we have things like FluentBit that are packaged as a part of these Tanzu additions as well. And as you start moving up the stack here, you get a little bit more feature rich, you get a little bit more capabilities as you move up. So when you move into things like Tanzu Standard, you get policy management, you get backup and restoration of the supervisor cluster in itself. You also get more visual cues into observability and monitoring with Prometheus and Grafana. You also get things to be able to do ingress with projects like Contour. And as you move up to the advanced stack is when you start getting into more capabilities that are looking more into the dev side of things. So as a technologist myself, you kind of want to think, well, all right, well, show me everything. And here is the slide that is everything. So you can kind of see here on the side of what are the core capabilities that you would need from anything from load balancing to ingress, logging, authentication, and management. And what does that equate to the different Tanzu versions, and the different Tanzu additions that we do have available to you. And one of the core features we're really going to focus on today is vSphere with Tanzu. And this is what we are utilizing to have those native integrations, those native hooks of Kubernetes with vSphere. And again, There are other components that are built into it, such as networking, such as load balancing, and we will get to all that as we go through here as well. But again, this just kind of shows you that sliding scale of different components that really encompass a full solution. So why vSphere or Tanzu? Why would you want to go this route? Well, we have different priorities. And as a former virtual admin myself, and knowing that many of you out there are as well, we don't want to go and learn a brand new technology. We don't want to go and now be Kubernetes experts or be Kubernetes admins. Instead, we have to still care and really think about the infrastructure that we monitor on a day-to-day basis. And really, this is where vSphere Tanzu creates a good delineation between what vSphere administrators can own and what developers own. So as a vSphere administrator, I am now able to provision and be able to segment off my infrastructure and deliver that in a way that is going to be creating availability. I can ensure cost control. I can also have quality of service all built into this, and it's all going to be programmatically done through things called vSphere namespaces, which we'll get to here in a second. And I provide that as a mechanism for my developers to then start consuming resources from the infrastructure that I own. Now, as a developer, this is great because I don't need to go and request virtual machines and build the Kubernetes clusters myself. Instead, what I'm being able to do is I can utilize the infrastructure that's been provided to me, and I can deploy as many Kubernetes instances as I want. I can support it, I can test it, I can do whatever it is. So lifecycle management is not owned now by the vSphere admin teams. Instead, it's owned by the application owners. So when you want new versions of Kubernetes, the new version is going to be dictated by the vSphere admin to say what Tanzu Kubernetes releases am I going to allow to run inside of my environment. And then once I apply that to the catalog, then developers or whoever else wants to utilize that image can go ahead and use it at that point. So I can still control security, images, and everything like that from a vSphere admin and a governance standpoint, whereas the developers still have a very self-service mindset. So with vSphere or Tanzu, there's really two ways to be able to do this. And one is the most basic way, and that's utilizing the virtual distributed switch. And when we utilize the virtual distributed switch, we get a few core services. Of course, we're able to integrate in with the network and storage services, so with cloud native storage and everything like that. But you also have the idea of the Tanzu Kubernetes grid service. And this is really what we call is creating Tanzu Kubernetes clusters as a part of vSphere with Tanzu. And we'll talk a little bit more about all these boxes in green as we start going through here. But you do have the ability, if you wanted to actually add on NSXT. And when you add on NSXT, it unlocks a few more capabilities. And namely, the first one is the vSphere pod service. This is actually running a pod in a lightweight CRX container, which is kind of like a very lightweight virtual machine that's running directly on the hypervisor itself. You also have the registry service. The registry service is Harbor, Project Harbor, that is deployed as vSphere pods. Now, if you don't have NSXT, it's fine. You're just going to be utilizing Tanzu Kubernetes grid service to actually create your Tanzu Kubernetes clusters for you. So here's a quick overview of vSphere namespaces and what do they mean. This is pretty analogous to what you would think with Linux namespaces. It is a way that we are now kind of creating a segregation of our infrastructure, but then we are also applying a few different policies to it. And namely within inside of vSphere, this is nothing more than a resource pool. It's a resource pool that has attached quotas. You also set things such as role-based access control into it, so on and so forth. But it really is a superpower for the vSphere admin to be able to set limits as well as what storage policies are attached to it as well. And within inside of this, Tanzu Kubernetes clusters, vSphere pods, virtual machines, they can all be provisioned as a part of this. So now I want to talk about Tanzu Kubernetes clusters, a little bit of the technical components as well as the architecture that goes into it. Now, Cluster API is the core technology that makes all of this possible because it is really the lifecycle management component. And VMware is a big contributor to Cluster API as well. So what does this look like or what does this mean? Well, in a nutshell, as a user, what I do is I specify some type of specification. And this specification says this is what my cluster looks like. It has this many worker nodes, this many controllers. These are the size of the virtual machines. And I provide that and I apply it to my management cluster. Now, the management cluster is nothing more than a Kubernetes cluster that has cluster API embedded, or should I say applied to it. Now, in the realm of vSphere or Tanzu, the management cluster is called a supervisor cluster. It's just a difference in the way that we provide that terminology. Now, once I apply that to the management cluster is now responsible for deploying our clusters to any type of infrastructure that we have provisioned, that we have applied or configured to it. Now, in the realm of vSphere or Tanzu, as you could guess, we are applying this to our vSphere environment. And we'll kind of look at a demo of what that looks like here in a little bit. Now, as a developer, this is great because I own the ability to deploy clusters at will. As a vSphere admin, I define the templates and the Tanzu Kubernetes releases, or what are called the images of Kubernetes that are going to be made available to my developers or to whoever is going to be owning these types of clusters. I also define the resource quotas, and I can monitor any type of resources that are becoming in contention or anything like that as well. But as the developer, I can now deploy as many clusters as I want, just making sure I'm in the bounds of my resource limits as well, and I have full control of it. These Tanzu Kubernetes clusters are also completely conformant, meaning that there is nothing that is being forked or anything that is being different. So 99% of the time, any application that you can run on any Kubernetes cluster will run on a Tanzu Kubernetes cluster because it's upstream and we are not manipulating it in any way whatsoever. Now, as a developer, it's really easy to get spun up utilizing a Kubernetes cluster. As we can see right here, this is all it takes within inside of a YAML or a spec right here. So within inside of this spec, I'm saying this is where the namespace where it's going to be deployed to. I specify the amount of control plane and worker nodes. And you can see right there in the class, there's two different. There's guaranteed and there's best effort. Now, we're all in the VIAdmin world for a while. Guaranteed is exactly what you would think of setting resource guarantees on a virtual machine. So we're setting resource guarantees. Best effort, no guarantees are applied to the virtual machine. And then you see medium and extra large. We have everything from extra small all the way to extra, extra large of how big these or how small these virtual machines can be. And it's dependent on you and how you want to provision or how you want to make that cluster perform. You also see the distribution, so we specify exactly which Kubernetes distribution we want, and that is going to equate to a Tanzu Kubernetes release that is available for us as well. And we also have storage classes. These storage classes actually come directly from vSphere. With inside of vSphere, we set labels that are applied to a particular data store, and then those labels are then applied to a virtual machine storage policy. Those virtual machine storage policies are then enabled through the vSphere namespace, and so now they are basically abstracted or they are shown here with inside of your Tanzu Kubernetes resources too. So that's how all that sort of flows up. And with inside of here, this is again, we can upgrade, we can delete, we can scale out from here, but we'll show a different way and more preferred way to be able to do that when we get to the demo. So here's a simplified workflow of what it looks like to provision a Tanzu Kubernetes cluster. So as a VIAdmin, I go through and I enable workload management on my vSphere cluster, and that is going to create our supervisor cluster. That supervisor cluster are 3 virtual machines that function as a Kubernetes control plane that has cluster API custom resources installed on it. After that, I create namespaces. So these namespaces have different configurations for role-based access control, content library access, which means what Tanzu Kubernetes releases are going to be available to me, what storage policies are going to be there, do I set limits on what CPU and memory can be applied to there as well. But after that, I'm done as a VIAdmin. Now a developer can take over. So as a developer, with inside of my local machine or virtual machine, I have my kubectl command or my kubectl vSphere plugin that is now downloaded to my virtual machine or my local machine. I use that to authenticate to the supervisor cluster utilizing vSphere SSO. This is a pretty important part because having vSphere SSO be directly connected to Kubernetes, I now get Active Directory and LDAP integration out of the box, which is very, very powerful because it's super, super easy to set up. So once I've authenticated, I can then set my context to the desired namespace, and then I go and I create Tanzu Kubernetes clusters by applying whatever cluster spec I want to that supervisor cluster, and it's going to go ahead and create the cluster for me without me having to do anything else. Now, I authenticate to the Tanzu Kubernetes cluster itself, and I deploy applications just as I would to any Kubernetes cluster at this point. So very, very simple to get going. After that, I just repeat the process over and over and over again. Now, the other thing is, as a developer, I want to have the ability to make sure that anything outbound can come into the cluster. And there's a few different ways that we can do that inside of Kubernetes world. You've got things like node port, but by and large, the most preferred way to do that is through ingress or utilizing load balancers. And we have the ability to automatically provision load balancers with vSphere or Tanzu. So we have the ability to do it with HA proxy, and we're also going to have the ability to do it with NSX Advanced Load Balancing Essentials, or what was actually coming from Avi. Now, this is very, very key because being able to go inside of Kubernetes, and all we have to do is say kubectl apply to a manifest that has a service in it. Once that service actually gets created, it's automatically going to pull an IP address from a load balancer and be able to pull that inside and be able to apply that to a running application inside of Kubernetes. So automatically provisioning a load balancers, there's nothing else that you need to do from a vSphere admin perspective other than making sure in the initial setup that you have all the IPs that are reserved for doing that. Now, we also have integrations into cloud native storage for vSAN as well. So this is pretty cool in regards that we're actually able to see all of the persistent volumes that are being provisioned as a part of vSphere or Tanzu inside of vSphere itself. We can also do correlation, so we can see exactly what persistent volumes or what disks are actually correlating to a container that's running. Now, this is also important to know because we typically think of a virtual machine having a disk tied to it. Now, the problem in a container world is that we need to make these persistent volumes independent, meaning that if a container is deleted or it's moved or it gets spun up somewhere else, we need to make sure that that disk can follow it wherever it goes. Or we can just say we can completely kill off an application, spin up a new one, and reattach that disk at a later time. So we have a different perspective on how persistent volumes actually flow in the realm of Kubernetes versus just being always attached to a virtual machine. We also have other things that are available to it. So we can now hook into things like Wavefront and Prometheus. As a developer, I can see more intricacies and more statistics that are actually happening from the storage side of things as well. Now, here's a little bit of an architectural overview. Now, the one thing about vSphere or Tanzu is that it utilizes something that we call paravirtual drivers, meaning that the supervisor cluster actually owns all the drivers of what the services are going to talk to, whereas the Tanzu Kubernetes clusters themselves only talk to the supervisor cluster. So inside of the Tanzu Kubernetes cluster, there is what's called the paravirtual CPI, or the cloud provider interface. This is going to be responsible for actually talking to the virtual machine service that's running as a part of the supervisor cluster. And this is going to be responsible also for creating virtual machines inside of vSphere to actually create these Tanzu Kubernetes clusters. It also gets other information on nodes and topologies. Now, if you want to provision a load balancer, same thing happens. It talks to the VM service, which talks to net operator, which pulls an IP address from HA proxy and applies that as a service to the Tanzu Kubernetes cluster. Well, we also have the paravirtual container storage interface. This is going to talk to the cloud native storage container storage interface, which then talks to vSphere's cloud native storage, which is going to be responsible for provisioning all the disks that are needed for persistent volumes. We also have the authentication proxy, which is of course going to rely on vSphere SSO, and we have single sign-on for Active Directory and LDAP. Lastly, we have what's also called a TKG service. Now, what this is going to do is it's going to expose different storage classes as well as permissions that are configured as a part of vCenter. Now, as I'd mentioned before, we talked about being able to have those labels that then get turned into storage classes or VMware or VM storage policies. Those are then exposed into the Tanzu Kubernetes cluster that then can be used to say this is where a persistent disk or a disk for a virtual machine will actually reside inside of the cluster. So what's the upgrade process look like? And this is a really cool thing that we'll show in the demo too, because as a administrator, you want to figure out, well, who owns what part of this? Well, new Kubernetes versions are synced through what we have as the subscribed content library. This is all done as a part of the setup of vSphere with Tanzu, and it's all in there in the doc, so very, very easy to find. So whenever we release a new Tanzu Kubernetes release, which is a new Kubernetes version, it'll automatically be synced back into your vCenter. Now, vCenter gets updates all the time, and we're pretty familiar with that. And vSphere with Tanzu updates are delivered as a part of vCenter. So the next step is to actually upgrade your supervisor cluster. This is, again, just a rolling upgrade of your supervisor cluster, which is your management cluster, which is nothing more than a control plane for Kubernetes. After that is done, we can then upgrade our Tanzu Kubernetes clusters independently whenever we want. So as a developer, now I would go ahead and I would go to the web interface where the supervisor cluster has its IP address, and I download the new kubectl and vSphere binaries. This gives me up to the latest version of what's available as a part of my supervisor cluster. After that, I go ahead and I update my Tanzu Kubernetes clusters. The preferred way to do it is actually editing the cluster directly, which we'll show in a demo here of actually being able to upgrade a cluster. So here's what the update experience actually does. As I mentioned, it happens in a rolling upgrade format. So patches and updates are delivered as vSphere updates. Once that is done, we then are syncing our content library as well to actually get any new Tanzu Kubernetes releases. So let's say within our environment, we are running version 1.x.a, but we want to run version 1.y.b. Well, what we're going to do is we're going to apply that cluster spec to the namespace where the supervisor cluster is running. Once we apply that cluster spec to there, what it's going to do, or we edit it directly, it's going to create a new virtual machine using the brand new Tanzu Kubernetes release or the new Kubernetes version. And what that's going to do, it's going to add it to the cluster. It'll join the cluster, and it will take over as the new controller for your Tanzu Kubernetes cluster. So if you're running one virtual machine, it takes a little bit longer to kind of go, but if you're running 3 control plane nodes, you're going to have the rolling upgrade as it's going to go. Now, the old version will actually be demoted and will be removed from the cluster. And then we actually start with the worker nodes. So we add a new worker node with the new Kubernetes version. And now what we want to do is automatically what's going to happen is the worker node will get a taint. And this taint means that no other containers will be provisioned or run to this particular machine. Instead, what's going to happen is it's going to now flush all the pods, meaning that all the pods will be killed, and Kubernetes, the control plane, is responsible for now restarting or respawning those containers onto another worker inside the cluster. Once that happens, the worker is then demoted and removed from the cluster. The same process goes over and over and over again until all of the nodes are remediated. So let's go ahead and let's jump into a demo. Within vCenter, we can see that we have our supervisor cluster provision and our first vSphere namespace created. Now moving to the terminal, I have already authenticated to my vSphere namespace, and we have a sample cluster ready to deploy. It has 1 control plane node and 3 workers with a default storage class that is being defined as the vSphere storage policy. After applying the cluster specification, vSphere begins the process of deploying the cluster. Now while we're here, we can see that creating a new namespace is relatively easy. Just supply a name and the network the virtual machines will be placed on that was configured as a part of the workload management setup process. Within an existing namespace, I can see an overview of information such as the health and the amount of Tanzu Kubernetes clusters that have been provisioned to it. I can add and edit permissions to the namespace. Again, this is all happening by integrating with vSphere single sign-on, and it makes authentication easier than lots of other Kubernetes distros that are out there. The storage policies define what is available to the cluster. If you remember, the Kubernetes storage policy is what was defined in our cluster specification, and these storage policies are comprised of tags that are applied to vSphere data stores. The VIAdmin has a superpower to set limits on resources for CPU, memory, and storage. This limit is set for both Tanzu Kubernetes clusters and vSphere pods combined. This is very critical to ensure that one namespace doesn't grow out of control and overutilize all your resources. And through the magic of video editing, we can see that the cluster is now up and ready. Scaling a cluster is easy as well. There are multiple ways to achieve this, but the easiest way is to edit the running cluster spec while being authenticated to the namespace. Within this file, I'm going to change the value to 4 for the worker nodes. And after saving the file, we can look at our vSphere environment, and within a few seconds, the new virtual machine will be up and running, and in a few minutes, it'll be joined to the cluster. Updating a cluster to the next version of Kubernetes is easy as well. We can investigate our Tanzu Kubernetes releases to see the latest available version, at least for right now, is 1.18.10. The cluster is currently running version 1.17.8. And to update this to the newest version, we edit the running manifest and set the full version to null. And then we could put in the full version and patch number if we wanted to, or if we could just specify the minor version of 1.18, and it's going to choose the latest patch for us automatically. After saving our changes, we can see the new control plane and the virtual machines that get provisioned in vSphere. To watch the entire process of the update experience, let's authenticate to the cluster itself. And after authenticating to the cluster and setting the context to our desired cluster, we can put a watch on the Git nodes and we can see the rolling upgrade process happen. This 5-node cluster will take about 15 minutes to complete the update. Now you've seen how one cluster operates, but how do we provision and manage many clusters, or even clusters across multiple clouds? And that's where Tanzu Mission Control comes in, and you get features such as policy management, backup and restoration, conformance checking, and much more, all starting with the Tanzu Standard Edition. Here's the Tanzu Mission Control web interface. We can create Tanzu Kubernetes clusters directly on AWS and vSphere, but we can also attach any Kubernetes cluster running anywhere, not just for visibility, but for also control. I can also perform upgrades and scale clusters directly from here too. Tanzu Mission Control has a number of policy types available, including access, image, network, security, quota, and even our own custom policies that are all built on top of Open Policy Agent. These policies can be applied to multiple clusters and everything is centrally managed. By drilling into a single cluster, I can see the overall health of it, and I can take it a step further in the Inspections tab. And you see those green checkboxes? That's a Sonobuoy conformance check and making it visible to you. We can even run CIS benchmarks, and we can set Valero backup schedules from the Data Protection tab too. And this is really only scratching the surface of what we can do with vSphere with Tanzu. We didn't even get into application deployment that requires load balancers or ingress controllers or utilizing Harbor to actually utilize our own images that we want to deploy into Kubernetes. And these are all a part of our Tanzu editions with basic, standard, and advanced. So just remember that vSphere with Tanzu is only just a small portion of the puzzle here. And there's even other options that get you across different clouds, backup and restoration, policy management at a global level. So make sure you go and check that out. But if you want to learn more, you got to get hands-on. Go and check out our Modern Apps Ninja courses from VMware. It's a free resource that allows you to get hands-on with it, as well as our hands-on labs. Make sure you do that. There is a vSphere with Tanzu course in there that allows you to spin up your own applications and spin up Kubernetes clusters, kind of as what we did in the demo today. If you need some basics on really what is Kubernetes and what is containers and that technology in general, go check out cube.academy. If you want to see the entire installation of vSphere with Tanzu, you can also check it out at this bit.ly link. It's a YouTube video that I created so you can see what it looks like from start to finish. And we also have the quick start guide and more technical content relating to vSphere with Tanzu. Thank you again for coming to today's session. I hope you found it valuable on being able to get your Kubernetes clusters up and running utilizing vSphere with Tanzu. You can follow me on Twitter at Kendra Coleman. I've also got some code samples at GitHub at KACold2. Thank you once again and enjoy the rest of your day.